we will start with the complex number function, but before I start with the complex function, I just remind you by the complex number. Okay, we know the complex number if I call it Z, complex numbers, this is the set of complex number. If I have any complex number in this set, it can be written in the Cartesian form as A plus IB. Or if you would like to write it in X and Y, I can go with U and X plus IY. Sometimes you write it as a point, X and Y. This is what we used to do in the Cartesian form. Any point here, X and Y, is exactly like a complex number, right? And the distance from here to here, they call it R, or the magnitude of Z, the magnitude. Okay, is the root square of the coordinates square. And also they call it the phase, or in mathematics they call it the argument. They call it theta. Theta, I go with you for tan minus 1 y over x, but you have to be very careful and know z lying in which quadrant. Okay, because the tan of 45 is the same as 135. So this is the main point you have to be very careful about using tan numbers. Okay, fine. And you catch theta from 0 to pi when you go with the anti-clockwise. And with the clockwise, you go from 0 to minus pi, right? This is a complex number in the Cartesian form, and in the polar form, z is r, open bracket, cosine theta plus I sine theta. Okay. And we know this is, they call it r e to the I theta, because r e to the I theta is the same as cosine theta plus I sine theta. This is, they call it Euler form. This is the polar form. And this is the Euler form, and this is the Cartesian form. This is a Cartesian form. Why I'm just repeating this one? Because exactly the construction of the complex function will be similar to the complex number. Okay, I just remind you, you have f of x is a real function. Okay, fine, but f of z will be is a complex function. Okay, now we know how to graph the f of x in 2 dimensions. This is y, which is f of x, and you can graph it whatever it is, right? But how to graph the f of z? Just let us see it first. We know f of z as a complex function. I can write it down as a real function, but is not in one variable, in 2 variables xy, because z is a function of xy, plus the imaginary part for another function of xy, of 2 variables, right? So this is the form of the complex function. This is a real function of two variable. And also this is a real function of two variable, right? This is the complex function. Let's have an example just to know. This is what I call it. This is, you call it the real part. This is, they call it the real part. And this is, they call it the imaginary part. Exactly like the complex number. We call x the real, and we call y the imaginary. Okay. Let's have an example for this one. Find the real part and the imaginary part of the first function e to the z, the second function is z squared, the third function is z bar, right? Can you do it, please? Yes, I'm hearing you. So what you are going to do here, this is exactly like E. What is E? What is Z? X plus IY. What you are going to do with the exponential function, you can factorize this one into e to the IY, right? Okay, that's good. Now e to the x, keep it outside. E to the IY, cosine y plus I sine y. Okay. So the real part, u equal to what? E to the x cosine y. The imaginary part, v equal to what? E to the x sine y. Catch it? Easy? Can you do z square for me, please? What is z square? Z bar is easy. It is x minus IY. So u will equal to x and the imaginary will be minus y, right? What's left? F of z square.
We make it x plus y square and then we expand
Yes, yes, yes. So what's u and what's v? It is difficult to multiply x plus IY times x minus IY. Sorry, x plus IY square.
Z to the power of x.
X is
sure. X square minus y
square.
plus
Plus with
minus
the u.
yeah, plus 2x IY. Oh no,
plus
this is the whole equation of
x.
oh.
The real part doesn't have I.
I'm talking about the whole equation.
No, I'm looking for the real and the measure.
Oh yeah, x squared minus y squared.
So x squared minus y squared, and the v will equal to what?
2xiyy.
Without I, Zain. I is indication for the imaginary, right?
Yes.
It is not involving in the function.
Yes.
Easy?
Yes.
Good news for me. Let's go for what we have done with the real function. Yes, the most important part is the derivative, right? Okay. So the derivative is very important, but don't worry. The derivative or differentiation of a complex function f of z follows the real function rule, real function rules. Okay, so don't worry about the derivative. It means if I would like to have d by dz for z to the power n, it will be what? Yes, n z n minus 1. If I would like to have d by dz for e to the z, or az if you like, so it will be a e to the az, right? Or you make it alpha, it's no problem. Okay, so don't worry about the derivative because you know the derivative of the real function and you are lucky you have the same. Do you know the point is what? Yes, I split the complex function into two real functions. This is the main point. So d by dz for sine z will equal to what? Yes, cosine z. And you can d by dz for len z will equal to 1 over z. And you can carry on, right? Is it difficult? But we have very special case. We don't have a conjugate for the real because the conjugate of the real is a real itself, right? If I am asking you, find d by dz for z bar, what you are going to do? You don't have such case in the real function, right? Do you? Of course not. But I know what is the definition of d by dx or by dz for any f of z. Yes, I know. This is the limit definition for delta z tends to 0 for f of z plus delta z minus f of z over delta z. Yes, when you're stuck, you go to the main definition of the concepts, right? Okay, let's go and do it this one. What's your f of z? It is z bar. Okay. What is z bar? It is x. Okay. Minus iy. Is it? Yes. Okay. You can write it like what? X and minus y to make it simple, right? What about f of z plus delta z? It means what? It means what? Can you tell me? Guys?
x minus iy.
Okay, so I have, instead of x and minus, sorry, so I will have x plus delta x and y plus delta y, right?
Yes.
So I will have minus here. Is it? Okay. Minus the original one over delta z is delta x plus I delta y, right? And I have to get the limit. Okay. Okay. So limit when delta x tends to 0 and delta y tends to 0. If I go for this one, okay, so I will have a different one, right? Sometimes I will have 1, and sometimes I have what? Minus 1, right? If I start with delta x tends to 0, I will have. So d by dz for z bar does not exist. Okay, because when I stack, I go for the original definition. Okay. In general, if you have f of z, a straightforward function in z like z to the power 5 minus e to the z plus sine z, and he's asking you find f dash of z, right? F dash of z. It is easy to say what? Solution. As I said, it will follow the same rule as a real function, so it will be 5 z to the power 4 minus e to the z plus cosine z. I finish. Okay. But what you are going to go, if I'm just giving you find f dash of z, f of z equal to e to the x cosine x plus I sine y. Okay, so I have x and y here. So what I'm going to do?
V add u?
So I cannot do this one, but I know this is what? This is e to the x, e to the iy, which is e to the x plus iy, which is e to the z. So I know it is easy to have f dash, okay, f of z will equal to e to the z, and I know f dash of z will be e to the z itself. So it will be e to the x cosine y plus I sine y. But what about if I have something I cannot change it into explicit function of z? Okay, so I need something to help me. Yes, I'm coming. We have something called analytic function. Analytic function, which has more power than the differentiation. Okay, so this analytic function, what is the definition of the analytic function? The complex function. It is, this concept is defined only for the complex function, right? The complex function f of z equal to whatever it is, okay, is said to be analytic it satisfies the Cauchy and Riemann equations. Okay, so this is corresponding to the analytic function. Fine, good. What's Cauchy? Says, yes, I know f of z, I can call it as the real part plus I, the imaginary part. What is a Cauchy-Riemann? Cauchy-Riemann says ux equal to vy and uy is equal to minus vx. This is the Cauchy-Riemann equation. This is the Cauchy and Riemann equations. If any one of this one fail, it will not be analytic. Okay, catch my point? Yes. Okay. Now, what you are going to do? I'll go back to my example here. Do you remember my example with this one? Okay. E to the z, z squared and z. Let's check this one. All of these one are differentiable, and we can differentiate e to the z, and we can differentiate z squared, and we can differentiate z. We cannot differentiate z bar, right? Let's check, are they analytic or not? Up to this definition of the analytic function. So I'll go for this example here. Is the following function number 1, f of z equal to e to the z, g of z equal to z squared, h of z, we call it z bar, right? Let's go for the first one. Before you start solving any question, write the information you are going to use to solve the question. Yes, I know. The analytic function, or the function f of z equal to u plus iv analytic f ux equal to vy and uy equal to minus vx. So I have to know the real part and the imaginary part of my complex function. Okay, let's go and say, is it analytic or not? Okay, now I need to know what is my first part, e to the z, my f of z is e to the z, and I know e to the z is e to the x plus iy, which is e to the x. I'm repeating many times this one just to catch it. And e to the iy, which is e to the x cosine y plus I sine y. So what's u and v? Yes, my u is e to the x cosine y, and v is e to the x sine y. Now let's go for the first equation. I need ux. When you differentiate partially, for x you keep the y as a constant, right? So I only differentiate e to the x, which is e to the x, and keep this one. This is not a multiplication rule here because I'm differentiating partially with respect to x. Okay, ux and vy equal to what? Yes, e to the x is constant, integrating with differentiating with respect to y, so it will be cosine y. Do you think this is the same? It is the same?
Yes.
Yes, so I have to mention this one. This is equal, this is number 1. Let's go for number 2. Uy equal to what? E to the x. What is the derivative? Minus sine y. Okay, that's good. What about vx? Vx minus vx is exactly minus e to the x sine y, right? Are they equal? Yes, they are equal. So what can I say? 1 and 2 implies that, sorry, f of z equal to e to the z is analytic. Easy? Okay. Can you take a screenshot from this one and put it in the chat?
Doctor.
Take this one also. Yes, it is easy to take a screenshot to make your own notes, right? Or even if you'd like to write it down, it will be easy for you instead of just watching the video all the time. Let's go for the next function, which is z square. Now, let's go for, we call it g of z equal to z square. What is z square as Zain tell us? It is x square, sorry, minus y square plus 2
2x
2i x or 2xy I. Okay, fine. So what is our u here? Yes, our u is x square minus y square. Our v is 2xy. Now let's go for the Cauchy Riemann. I'll go for ux. What's ux? I'll keep y as a constant, so I differentiate for vx. And vy equal to what? I keep 2x as a common factor, as the derivative of y is 1. Are they equal?
Yes.
Yes. So this is my first equation of Cauchy and Riemann. One for Cauchy, one for Riemann. Let's go for, let's choose a nice color. I like colors. Go for uy equal to, yes, x is a constant, so the derivative of x squared is 0 minus 2y. What about minus vx? I keep y as a constant, so I have 2y. Okay, are they equal? Yes, they are. So this is my second question. So 1 and 2 implies to j of z, which is z square, is analytic. Okay, let's go for the last one. Sorry. What's our function? H of z equal to what? Z bar. What is z bar? Yes, I know. It is x minus iy. So what's your u? Is x. What's your v? Minus y. What is you? Oh, sorry. Let's go for it using nice colors. I like colors. This one. What about ux? Is it 1?
1. Yes.
What about vy?
0. 1, sorry.
Minus one.
Minus one.
Minus 1.
Minus one. Are they equal?
No.
No.
No. No need to complete, right? So h of z equal to z bar is not analytic. So yes, if it is not analytic, it will not be differentiable, right? Catch it? Can you take a screenshot from this one?
Done.
Thank you. Now let's link this one for our derivative if we don't have explicit function of z. We have a explicit function of u and v, right? Okay, as two imaginary and real parts. We know the link between the derivative and Cauchy-Riemann. We know if we have f of z equal to u of x and y plus I v of x and y. Okay, that's good. Okay. Look at the definition of the derivative. Yes, I know the derivative is a limit. So if I go for f dash of z, I have the limits. Yes, when delta y tends to 0 for what? Yes, when I change the y, so I have u of x and y plus delta y minus u of x and y. So when you make a change in y, you go for the limit over I delta y. This is the change of z in the direction of y. Yes, plus I. Okay, and I go for the other part, limit when delta y tends to 0, right? When I make the change in the direction of y, but I'm going for v this time, x and y plus delta y minus v of x and y over, yes, I delta y. So good. So what is this one? This is the derivative with respect, this is the derivative of y, right? Of u. So this is u with respect to y plus I and v with y. This is the definition of the first derivative. Okay? As simple as that. You can do the same, right? So this one will be minus, okay? Fine. Up to Cauchy-Riemann, what is uy? Yes, I just remind you, what is uy? Is minus vx, right? So this one will be minus vx plus I. What is vy? What is vy with the Cauchy-Riemann? Vy equal to vx, right? Catch my point? Okay. So you can keep it like this one, or you can keep it, sorry, this is ux, sorry, because vy is ux. Catch my point? So I replace minus uy by, sorry, ux. If I make it this one. Sorry, I missed this one. This is positive. This is the negative is here. So we have to change this. This is the minus. Okay, so I have ux plus ivx plus ivx. So you have the choice of having the first derivative, right, using differentiation with respect to x for u and v, or differentiation with respect to y with for u and v, right? So I have ux plus ivx. If I would like to change this one using Cauchy Riemann, I just make it down this one. Okay. If I would like to have it in differentiation of y only, so I have vx is minus is uy is vy, sorry, vy, and vx is minus uy. So yes, I can differentiate with respect to x only for u and v, real part and imaginary part, or I can differentiate with respect to y for the real and the imaginary part. But remember, if you go for x, you start with u, right? And the imaginary will be v. But when you start with differentiating with respect to y, your real will be vy and your imaginary will be minus uy. Catch it? You said we are following the rule of sorry the rule of derivative of a real function. Yes, I said this one when you have a complex function as a function of z, explicit function of z, and we know z is x plus iy, so we have a real part and imaginary part. So our f of z is not all the time z to the power or ln or cosine z, or we have uxy as a real part of my complex function plus I, the imaginary part. Okay, let's go back for any example for this one to have the derivative of that one. If we have this function sorry, find f dash of z, f of z is u of x y plus I v x y with, once I give you u equal to x times y, and in the second part I will give you the imaginary part v equal to xy. So yes, now you are not going to follow the real function rule for the f of z. You go for your special case for the derivative. Yes, I know, if I know the real part and the imaginary part, I can go for this one. So what if if I have only one part? Yes, don't forget with the Cauchy Riemann, what's Cauchy Riemann said? It said ux will equal to what? Vy, right? And uy equal to what? Minus vx. So yes, I can replace this one by what? Minus uy. Catch it? Okay.
Yes.
Okay, right? So I can have the formula for this one. Okay, if I know one of the parts of my function, I can find the other, the derivative, right? It's no problem if I have only one part of my function to have the derivative. This is the most important part in the complex function. Okay. So now I know f dash of z is what? Ux plus what? Ivx. But I have only u. So what I'm going to use? I'm going to use the Cauchy-Riemann equation to replace the Vx by minus Uy, right? If I have V, so I will replace Uy by what? Yes, plus minus Vx. Catch my point or not?
Catch.
Okay. So this is the point of using Cauchy-Riemanning. Okay. So if I have U, if you have F given U, X, Y, you have F dash of Z equal to what? Ux minus Iuy, right? If you are given the imaginary part, what is your derivative in this case? You have Vy, what? Plus Ivx, right? Please take a screenshot for this too, please. So if I go for the first one, you given U, right? Sorry. This is given, right? When you given Uxy, the real part, when the real part is given, you are going to use what? F dash of Z will equal to what? I'll back and to just remind you. Ux minus Iuy, right? Ux minus Iuy. Okay, let's go for Ux. What is Ux? It's partial by partial x for U. So it's partial by partial x. What's my U? X and Y. Yes, it is Y, right? Now I'm looking for Uy. What's Uy? Is the first derivative with respect to Y for my real part, which is the given one. Catch it? Now partial by partial y for x, y, which is x. Now I'm just going to replace all of this one here, right? So f dash of z equal to what? Ux, y minus ix, right?
Yes.
Can you do part 2 and put it in the chat, please? Anyone done it? Thank you, Amna, very much. Yeah. Also take a screenshot from this one also and put in the chat.
I forget the I.
Okay. And take a screenshot for this one also. Just to have a complete note. In the second part, you are given the imaginary part. Anyone take a screenshot from this one and put it in the chat until we have the second part?
Yes, done.
Thank you. Yes. Who's done this one for us?
Me, doctor.
Do you think f dash without the I? It is x plus iy, right? But this one, I'm afraid anyone will take it as this is a real function. This is not a complex function, okay?
Yes, yes, I forget it in the first
Okay,
equation.
so I will take this one here. Okay. And I will got for this is 2. Is it 2? Yes. Okay, I'm just remind myself. Vy plus I Vx. Vy plus I Vx. So this is the right one. Thank you. Okay. Easy. Now we will go for a new concept coming from the Cauchy-Riemann also. Any one of you remember the Laplace equation? Yes, we got it in the vector, right? I just remind you what Laplace equation is. Nabla square. Okay. I call it for anything. For u is what? Uxx plus uyy. If you are in 2 dimensions, that's enough. Equal to what? Equal to 0. Remember this one? Okay. Yes.
Yes.
If you would like to write it as a normal notation, okay, this is in 2 dimension. In the 3 dimension, we don't care about the 3 dimension here because we have x and y. Now let's start with the Cauchy-Riemann. From the Cauchy, and Riemann equations. What we have in the Cauchy-Riemann, yes, I remember, ux equal to vy, this is the first one, and uy equal to minus vx, this is the second one. Now what I'm asking you to do, just differentiate u number 1 with respect to x. What do you have now? Yes, you have xx, right? Equal to v xy. So I call it 1 dash. Now do the same, but for 2, but differentiate with respect to what? Yes, I'm hearing you. With respect to what?
Y.
Y, to have Laplace. This is why I give you the introduction. Good. So what do you have? Vyy equal to minus Vyx, right? and we call this one 2 dash. Now just sum these two together. Okay, sum these two together. What do you have? I know Vxy equal to Vyx. Okay, so when I'm just summing this one will be cancelled with this one, right? So what I am having to do here, I have Vxx plus Vyy equal to what? Okay, yes, this is a Laplace equation in 2 dimension for my V equal to 0, right? Sorry, for my U. Oh, sorry. This is Uxx. I'm just write it again. Sorry. Okay, so you have Uxx plus Uyy equal to 0, right? So yes, this is Laplace square U equal to 0. This is the Laplace equation. Okay, so for the real function, okay, for the real function, the real function U of x or y such that Laplace square U equal to 0, okay, I call this one, if I my U satisfying this one, I call this one U of x or y is a harmonic equation. Is what? Yes, harmonic equation. Is harmonic. Okay, so what does it mean, this one? It means if I have the real part of my complex function is harmonic, I can find the V, the other part of my, yes. This is why when you have one piece, the real part of your, the imaginary part of your wave, you can find the real part or vice versa, right? Yes, this is a point of doing this one. Okay, so I have Uxx plus Uyy equal to 0. Catch my point? So we have two concepts today. Concept called what? Analytic function and harmonic function. Okay, but this analytic function for a complex function, but this harmonic for two variable real functions. So you have to distinguish between the concept, one for the real two variable function, and the analytic is for a complex function. What is the connection between this one? Yes, this real function could be the imaginary part of f of z ux and y plus I vx and y. So yes, I prove f my u x or y is harmonic. So what? So I can find, we can find analytic function f of z with the real part u of x or y plus the imaginary part. Okay, that's good. Let's have an example for this one. If I give you the real part and you check it is harmonic or not, you can find the other part to mix it together to have the complex function. Let's do it. Let u of x or y equal to e to the x cosine y is the real function okay, let's go. Okay, now what you need first is u of x or y harmonic if explain if yes, find the analytic function f of z equal to u of x or y plus I v of x and y. So you have u, you are looking for v. Let's go together. What does it mean harmonic? So I have to write the definition. U or x and y is harmonic if what? uxx plus uyy equal to what? Yes, 0. Now let's do it and check. First, I have to find the first derivative. What is ux? It is e to the x cosine y. What is uxx? It is also e to the x cosine y because I'm differentiating with respect to x. So everything with y, I take it outside the derivative of x. Now, uy is equal to what? Minus, yes, e to the x sine y. What is uyy? Yes, it is minus e to the x. The derivative of sine is cosine y. Yes, add them together to have uxx plus uyy equal to what? 0. So it is harmonic. So u equal to e to the x cosine y is harmonic. Can you take a screenshot, please? In the next part, please concentrate as much as you can. Okay. Now we'll go for the next part. I am given u equal to e to the x cosine y. This is the given. Given what? The real part. I'm looking for what? Just to know my yes. To find f of z equal to u plus iv, I have to find what? So I'm looking for v Yes, I know, I'm looking for V. Fine. How I can get this one? Yes, using Cauchy-Riemann. Equations. What's Cauchy-Riemann? Just remind me again. Yes, Ux equal to what? Vy, this is number one. And Uy equal to what? Minus Vx. This is number two. Now let's start to do this one. What is Ux? You just differentiate here. It is e to the x cosine y, right? E to the x cosine equal to, I don't know anything about y, so this is number one, okay? Again, yes, I'll go for this one. What is my uy? Yes, here it is. It is minus e to the x sine y. Yes, I have two differential equation because Vy is partial V by partial Y, right? So what I'm going to do, which one I'm going to integrate? Anyone, it doesn't matter, right? But I think I make a mistake here.
Doctor, it's
This
equal
is V, yes,
minus.
this is V, minus Vx, yes, I catch it. Thank you very much. Because I found this is the same thing. So yes, I can cancel out this minus with this minus, right? Fine. What else? I can start with any one. You can integrate any one of them. Which one you like? Yes, I'll go for this one. So this is how you write this down. This is V will be the integration of e to the x cosine y partially with respect to what? Y, right? So what is the integration? E to the integrating with respect to y, so you take e to the x outside, right? And integrating cosine y partially with respect to y. So what do you have now? What is this integration result? E to the x. What is the integration of cosine? Sine y. Plus a constant, right? But this constant should be a function of what? Of x. Okay? Yes, it is a function of x because I consider x as a constant because this is partially integrating. Okay, I know this is what? This is my v, right? Okay, this is what? This is what? This is a v. I find v, yes, you find v, but you still have this one to find, right? This is the point of using the second derivative, okay? The second equation, sorry. So after I finish integration, I differentiate with respect to what? To what? Yes, to x, to use the Vx, right? So what do you have from this one? When you differentiate with respect to x, so you have Vx equal to what? Guys, what is the derivative? It is e to the x sine y. And yes, this is a real function, so you don't write a partial derivative. You write a complete derivative. So you have dh by dx. I know from 2, this Vx, from 2, I have this Vx equal to what? Yes, e to the x sine y, right? Yes, I can cancel out this one with this one. Okay, so what's left? dh by dx equal to what? 0, right? So dh by dx equal to 0. What does it mean? When you have a derivative equal to 0, okay, your function should be what? A constant function, right? I call it C, right? Now I go back to V and I find the missing part, which is H, right? Catch it? So after you get this one, your V will equal to what? E to the x sine y plus C. Okay, now what is my answer now? I'm looking for this one. I given you, what's u? E to the x cosine y. Plus I, what is v? I got v myself, which was what? E to the x sine y plus c. E to the x sine y plus c. This is the analytic function he's looking for. Easy? Using Cauchy-Riemann equation, you have one part, u or v, so you have two differentiation for the same function, u or v. Integrate any one of them, but remember, when you're integrating partially with respect to y, you have a constant as a function of x. But if you integrate this one with respect to x, you have your constant as a function of y. This is very important part, right? Do you have any question before we move?
No, thank you, doctor.
There are some exercise, right? I will put it for you right now in the chat, or I put in the e-learning. So please try to solve the exercise, okay? And inshallah, we will meet together inshallah on Wednesday. I stop recording now and I put you the exercise.